Question 1. In the context of biohazard remediation, Mr. Alvarez is called to a commercial building where the HVAC system shows visible mold growth on the cooling coils. He needs to ensure effective decontamination without spreading spores. What should Mr. Alvarez do first? A. Apply a strong bleach solution directly to the coils. B. Shut down the HVAC system, establish negative pressure in the affected area, and seal off ducts. C. Increase system airflow to disperse airborne spores before cleaning. D. Remove the coils immediately and transport them outdoors for cleaning. Answer. Correct answer. B. Explanation. Establishing negative pressure and containment is critical to prevent cross-contamination during mold remediation. Directly applying bleach without containment can aerosolize spores, increasing exposure risk. Increasing airflow spreads contaminants rather than removing them, and removing coils without containment risks contaminating other areas. This approach aligns with best practices in HVAC biohazard remediation, emphasizing containment first, followed by cleaning using proper disinfectants under controlled conditions. Question 2. During a post-flood remediation project, Thompson observes that the ductwork has high humidity and condensation inside, risking microbial growth. Which of the following actions best addresses the situation while minimizing potential biohazard spread? A. Install UV lamps immediately to kill pathogens. B. Dry the ducts using controlled dehumidification before conducting cleaning. C. Spray the ducts with disinfectant without drying. D. Seal the ducts and resume normal HVAC operation. Answer. Correct answer. D. Explanation. Sealing ducts and resuming operation without drying is incorrect. The proper approach is controlled drying before any disinfection, as moisture promotes microbial growth. UV can supplement disinfection but is ineffective if the surface remains wet. Spraying disinfectant on wet surfaces may dilute or inactivate the chemical and risks spreading contaminants. Controlled drying combined with containment and filtration prevents further growth and adheres to biohazard remediation standards for HVAC systems. Question 3. Given the circumstances, Mr. Lee is assessing a medical facility's HVAC system after reported viral contamination. He needs to ensure the correct respirator selection for his team. Which principle should guide Mr. Lee's choice? A. Select respirators rated for general dust protection. B. Use respirators with appropriate PRN ratings based on pathogen size. C. Choose the lightest, most comfortable respirator to maximize compliance. D. Only require respirators in visibly contaminated areas. Answer. Correct answer. C. Explanation. Selecting respirators solely based on comfort is unsafe. Biohazard remediation requires respirators rated for the size of the pathogen and for airborne viruses, P for fine particulates. General dust masks provide inadequate protection, and relying only on visible contamination ignores aerosolized pathogens. Proper respirator choice is guided by the OSHA Respiratory Protection Program, ensuring filtration, fit testing, and adherence to safety standards for airborne biohazards. Question 4. From the perspective of system design, Mr. Patel must remediate an HVAC system in a high-rise building contaminated with airborne bacterial spores. He is considering HEPA filtration integration. What is the most effective approach? A. Install temporary HEPA filters only at supply vents. B. Place HEPA filtration at return and exhaust points to capture contaminants. C. Rely on existing filters and increase fan speed. D. Remove filters entirely and perform UV irradiation only. Answer. Correct answer. B. Explanation. HEPA filtration is effective when positioned at points where contaminated air is drawn into the system, typically return and exhaust ducts. Installing only at supply vents risks recirculating spores. Increasing fan speed without filtration can spread contaminants. UV alone does not remove particulates. Proper HEPA filter placement, along with negative pressure containment, ensures airborne pathogens are captured effectively, consistent with advanced HVAC biohazard remediation principles and OSHA guidelines. Question 5. When considering chemical disinfectants, Carter must remediate ductwork contaminated with MRSA bacteria. She wants to choose a disinfectant that ensures both efficacy and material compatibility. Which action reflects best practice? A. Use a high concentration bleach solution indiscriminately. B. Review the SDS and select an EP registered disinfectant compatible with HVAC materials. C. Mix different disinfectants to increase potency. D. Rely on mechanical cleaning alone without chemicals. Answer. Correct answer, B. Explanation. Selecting an EPA-registered disinfectant ensures efficacy against the target pathogen while minimizing damage to HVAC components. High-concentration bleach can corrode metal and degrade insulation. Mixing disinfectants risks dangerous chemical reactions. Mechanical cleaning alone may remove debris but cannot reliably kill pathogens. Consulting SDS and selecting a compatible, validated disinfectant aligns biohazard remediation standards and promotes worker safety. Question 6. Across different scenarios, Mr. Huang encounters a hospital HVAC system with suspected viral contamination. Airflow measurements reveal high leakage around duct joints. What remediation principle should guide his next step? A. Increase system airflow to compensate for leaks. B. Seal leaks using approved duct sealant before initiating disinfection. C. Ignore minor leaks, focusing only on visible microbial growth. D. Remove sections of ductwork and replace without sealing. Answer. Correct answer, C. Explanation. Ignoring leaks is unsafe. Leaks allow contaminated air to escape, posing infection risks. Increasing airflow spreads pathogens, and removing duct sections without sealing can contaminate other areas. Sealing leaks first ensures containment and maximizes the efficacy of subsequent cleaning and disinfection. Proper sealing and maintenance of airflow integrity follow industry best practices for biohazard HVAC remediation and are recommended by guidelines for pathogen containment. Question 7. During a biohazard assessment, Rivera observes a dehumidification unit with visible microbial growth in the condensate pan. She plans remediation while minimizing disruption to hospital operations. What should be her approach? A. Remove the unit immediately for off-site cleaning. B. Establish containment around the unit and perform on-site cleaning using appropriate disinfectants. C. Spray the surrounding area liberally to ensure surface sterilization. D. Ignore the unit since microbial growth is isolated. Answer. Correct answer, D. Explanation. Ignoring microbial growth is unsafe and may exacerbate contamination. Removing units without containment risks spreading pathogens. Spraying surrounding areas without containment may disperse contaminants. On-site cleaning under proper containment using approved disinfectants and PPE prevents cross-contamination while allowing continued operation. This approach aligns with standard biohazard remediation practices, emphasizing containment, proper chemical use, and minimal operational disruption. Question 8. In light of recent developments, Mr. Johnson must conduct post-remediation verification in a commercial building. He needs to ensure all surfaces and airflow are safe. Which action represents proper protocol? A. Rely solely on visual inspection of ducts and coils. B. Conduct surface swabs and air sampling per validated biohazard testing methods. C. Only test areas where workers complained of odors. D. Perform a single test at the system return vent. Answer. Correct answer, A. Explanation. Visual inspection alone is insufficient as pathogens may remain undetected. Post-remediation verification requires systematic sampling of surfaces and air following validated testing protocols to confirm biohazard reduction. Testing only areas with odors or a single location does not ensure overall safety. Comprehensive testing ensures compliance with standards, validates the effectiveness of disinfection, provides documented evidence for regulatory and client requirements. Question 9. Considering the evidence, Williams is tasked with remediating a laboratory HVAC system contaminated with aerosolized bacteria. She wants to minimize airborne dispersal during cleaning. Which technique best addresses the issue? A. Use high-pressure air hoses to remove dust from duct surfaces. B. Clean using HEPA filter vacuums and wet methods under negative pressure. C. Remove insulation material and shake it outdoors. D. Increase supply airflow to push contaminants toward exhaust vents. Answer. Correct answer, B. Explanation. HEPA filter vacuums and wet cleaning under negative pressure minimize airborne spread and ensure containment. High-pressure air disperses pathogens, shaking insulation outdoors risks uncontrolled contamination, and increasing airflow spreads biohazards. Using containment, proper vacuuming, and wet cleaning aligns with HVAC biohazard remediation standards and ensures worker safety while effectively removing microcontaminants. Question 10. Throughout the course of a remediation project, Mr. Ahmed must handle waste from contaminated HVAC components, which procedure reflects compliance with best practices for biohazard waste disposal. A. Dispose of contaminated filters and insulation in standard trash bins. B. Bag waste in double-labeled biohazard containers and follow local regulations. C. Burn all contaminated materials on site to ensure sterilization. D. Store contaminated waste in open areas until pickup. Answer. Correct answer. D. Explanation. Storing contaminated waste in open areas is unsafe and non-compliant. Proper disposal requires double bagging in labeled biohazard containers, following EPA, OSHA, and local regulations to prevent exposure and environmental contamination. Standard trash, on-site burning, or open storage poses serious health risks. Adhering to regulatory guidelines and using proper labeling and containment ensures legal compliance and safety during HVAC biohazard remediation. Question 11. While examining a commercial HVAC system is new and notices that several air handling units show evidence of water intrusion and mold growth on evaporator coils, she needs to decide how to remediate the system without spreading contaminants throughout the building. What should be her immediate action? A. Increase system airflow to dry coils faster. B. Establish containment, shut down affected units, and isolate ductwork. C. Apply disinfectant to all ducts immediately. D. Remove the coils and transport them to another location for cleaning. Answer. Correct answer. B. Explanation. Immediate containment and shutting down affected units prevents airborne spores from spreading. Increasing airflow would disperse contaminants. Applying disinfectant without containment risks cross-contamination, and removing coils without proper containment can contaminate other areas. Following proper HVAC biohazard remediation procedures, negative pressure zones and isolation are prioritized before cleaning to protect occupants and workers in line with OSHA and EPA recommendations. Question 12. Given the circumstances, Mr. Roberts is evaluating the airflow in a hospital wing where a viral contamination event occurred. He wants to reduce the risk of pathogen spread through the HVAC system. Which approach best mitigates this risk? A. Use HEPA filtration at return vents and maintain negative pressure in the contaminated area. B. Increase supply airflow to push contaminants toward exhaust vents. C. Rely on OVG alone in the supply duct to deactivate pathogens. D. Seal all return vents to prevent recirculation. Answer. Correct answer. A. Explanation. HEPA filtration at return vents captures airborne pathogens and negative pressure prevents contaminated air from escaping the isolated area. Increasing supply airflow risks spreading pathogens. OVG alone does not remove particulate matter, and sealing return vents without controlled airflow can create pressure imbalances and further contamination. Combining HEPA filtration with negative pressure aligns with advanced biohazard remediation best practices. Question 13. From multiple perspectives, Ms. Johnson is remediating a building exposed to bacterial contamination. She must select appropriate PPE for her team. Which principle should guide her decision? A. Select PPE based solely on what is most comfortable for the workers. B. Choose PPE that protects against the specific pathogens present, including respirators, gloves, and suits. C. Use general-purpose work gloves and standard dust masks. D. Require PPE only in visibly contaminated areas. Answer. Correct answer. B. Explanation. PPE selection must match the pathogen risk, ensuring respirators, NP, gloves, and protective suits are used even in areas without visible contamination because airborne pathogens may spread. Comfort alone or minimal PPE provides inadequate protection. Following OSHA respiratory protection standards, PPE selection is critical for safety and regulatory compliance in HVAC bioremediation. Question 14. When faced with a flooded HVAC system in a data center, Kim notes significant water in ductwork and air handlers. You must prevent microbial growth while maintaining safety. Which action is most appropriate? A. Begin mechanical cleaning immediately without drying. B. Perform controlled drying using dehumidifiers and air movers before disinfection. C. Apply disinfectant liberally while the system is wet. D. Operate fans at maximum speed to push moisture out. Answer. Correct answer. C. Explanation. Applying disinfectant to wet surfaces can dilute or inactivate the chemical, and using fans or mechanical cleaning without drying spreads contamination. Controlled drying removes moisture that promotes microbial growth. Only after drying should disinfection occur. This aligns with water damage restoration and HVAC biohazard remediation protocols, emphasizing moisture control first to ensure effective decontamination. Question 15. In the modern context of HVAC biohazard remediation, Isley observes that a facility's duct insulation is contaminated with fungal spores. What is the best practice for remediation? A. Leave insulation in place and clean it using high-pressure air. B. Remove contaminated insulation carefully under containment, then replace or clean with approved methods. C. Spray disinfectant over insulation while leaving it in place. D. Ignore insulation and focus on coils and ducts only. Answer. Correct answer. D. Explanation. Ignoring contaminated insulation risks persistent microbial growth and cross-contamination. High-pressure air disperses spores, and spraying disinfectant without removal may be ineffective. Proper remediation requires careful removal under containment and either replacement or thorough cleaning. This follows industry standards for HVAC biohazard remediation, prioritizing containment, PPE, and decontamination of all contaminated system components. Question 16. As illustrated by a recent biohazard incident, Singh must validate post-remediation air quality in an office building. Which approach provides reliable verification? A. Conduct comprehensive surface swabs and air sampling following validated testing protocols. B. Perform only a visual inspection of ducts and vents. C. Rely on feedback from occupants about odors or symptoms. D. Test a single return vent as a representative sample. Answer. Correct answer. A. Explanation. Post-remediation validation requires documented evidence of pathogen removal. Comprehensive surface and air sampling ensures areas are safe. Visual inspection or occupant feedback is insufficient to confirm effective decontamination, and a single vent does not represent system-wide safety. Following validated protocols provides objective, regulatory-compliant verification supporting safety and standards in HVAC biohazard remediation. Question 17. During the process of remediating a laboratory HVAC system, Ahmed notices that airflow leaks exist around duct joints. Which remediation principle best addresses this risk? A. Increase system airflow to compensate for leaks. B. Seal leaks with approved duct sealant before cleaning and disinfection. C. Ignore minor leaks and focus on visible microbial contamination. D. Remove ducts without sealing leaks. Answer. Correct answer. C. Explanation. Ignoring leaks is unsafe as air leakage can transport pathogens to other areas. Increasing airflow spreads contaminants, and removing ducts without sealing risks exposure. Proper procedure involves sealing leaks with approved sealants to maintain containment integrity and ensure cleaning and disinfection are effective. This practice is consistent with biohazard remediation guidelines, prioritizing containment and air control. Question 18. Through careful analysis of a building HVAC system, Garcia identifies a condensate pan with persistent bacterial growth. What is the recommended remediation approach? A. Spray surrounding areas with disinfectant to eliminate bacteria. B. Remove and clean the pan on site under containment using approved disinfectants. C. Ignore the pan if the growth is minimal. D. Replace the entire air handler without cleaning. Answer. Correct answer. B. Explanation. The condensate pan is a key site for microbial growth. On-site cleaning under containment ensures bacteria are removed without spreading. Spraying surrounding areas or ignoring the pan is insufficient. Replacing the air handler unnecessarily increases cost and risk. Following containment and proper disinfectant application ensures compliance with biohazard remediation standards and OSHA guidelines. Question 19. To illustrate this point, Martinez is handling biohazardous waste from contaminated HVAC components. Which procedure reflects proper disposal according to safety standards? A. Double bag and label waste in approved biohazard containers for regulated disposal. B. Place waste in standard trash bins to be collected with regular garbage. C. Burn contaminated materials on site to ensure sterilization. D. Store waste in open areas until pickup. Answer. Correct answer, D. Explanation. Open storage of contaminated waste is unsafe and violates OSHA and EPA regulations. Proper disposal involves double bagging in labeled biohazard containers and following local, state, and federal guidelines. Standard trash collection or on-site burning is non-compliant and risks environmental contamination. Adhering to these protocols ensures worker safety and regulatory compliance in HVAC bioremediation. Question 20. Across different scenarios, Mr. Patel must remediate a system after viral contamination in an office. He wants to minimize airborne dispersal during duct cleaning. Which technique is most effective? A. Use high-pressure air to dislodge debris. B. Clean with HEPA filter vacuums and wet methods under negative pressure. C. Shake insulation outdoors to remove contaminants. D. Increase supply airflow to push contaminants toward exhaust vents. Answer. Correct answer, B. Explanation. HEPA filter vacuums and wet cleaning under negative pressure prevent airborne pathogen dispersal. High-pressure air shaking insulation outdoors or increasing airflow spreads contaminants, creating cross-contamination risks. Using containment, proper vacuuming, wet cleaning, and negative pressure follows best practices for HVAC biohazard remediation, ensuring both worker safety and effective pathogen removal. Question 21. In the context of HVAC biohazard remediation, Mr. Dawson is evaluating a building where previous water damage led to mold in the ductwork. He wants to prevent spores from spreading during cleaning. Which approach is most effective? A. Increase system airflow during cleaning to push spores out. B. Establish negative pressure and isolate affected sections before cleaning. C. Spray disinfectant on the ducts immediately without containment. D. Remove duct sections and clean outdoors. Answer. Correct answer, B. Explanation. Negative pressure and containment prevent airborne spores from spreading. Increasing airflow or spraying disinfectant without containment disperses pathogens, risking cross-contamination. Removing duct sections outdoors can spread contaminants if not properly contained. Industry standards emphasize isolating the area and controlling airflow before cleaning to ensure safe and effective HVAC biohazard remediation. Question 22. Which of the following best reflects proper post-remediation verification for Mr. O'Connor's recently decontaminated office HVAC system? A. Rely on visual inspection alone. B. Conduct systematic surface and air sampling per validated protocols. C. Ask occupants if odors are gone. D. Test only the supply vents for pathogens. Answer. Correct answer, C. Explanation. Asking occupants about odors is not sufficient for verifying biohazard remediation. Visual inspection alone misses unseen microbial growth, and testing only supply vents provides incomplete data. Systematic surface and air sampling ensures pathogens are removed and validates remediation effectiveness. This approach aligns with OSHA and EPA guidelines for biohazard verification, providing documented evidence. Safety compliance. Question 23. During a hospital HVAC remediation, Patel notices that condensate pans are producing odors indicative of microbial growth. What is the most effective course of action? A. Ignore the odor if it is minor. B. Clean and disinfect condensate pans on site under containment using approved methods. C. Spray nearby surfaces to mask the odor. D. Remove and replace the entire air handler unnecessarily. Answer. Correct answer, B. Explanation. Cleaning and disinfecting condensate pans under containment addresses the microbial source directly. Ignoring minor odors or spraying nearby surfaces only masks the problem, while unnecessarily replacing equipment increases cost and may not address underlying contamination. Proper remediation follows containment, PPEs, and EPA-approved disinfectants to safely eliminate microbial growth and pathogen spread. Question 24. Given the circumstances, Mr. Edwards is remediating duct insulation contaminated with fungal spores. Which method aligns with biohazard remediation best practices? A. Leave insulation in place and clean using high-pressure air. B. Carefully remove contaminated insulation under containment and replace or clean appropriately. C. Spray disinfectant over the insulation while leaving it in place. D. Focus cleaning only on coils and ducts, ignoring insulation. Answer. Correct answer, D. Explanation. Ignoring contaminated insulation is unsafe as it can harbor microbes that continue to spread. High-pressure air disperses spores, and spraying disinfectants without removal may be ineffective. Proper practice involves removal under containment and safe cleaning or replacement. This approach minimizes cross-contamination and ensures compliance with industry standards for HVAC biohazard remediation. Question 25. From a practical standpoint, Mr. Zhao must select respirators for his team during a viral HVAC contamination remediation. Which principle should guide selection? A. Choose respirators based solely on comfort. B. Select respirators rated for the specific pathogen particle size e.g. N or P. C. Rely on standard dust masks. D. Require respirators only where visible contamination exists. Answer. Correct answer, B. Explanation. Respirators must match the pathogen size to provide effective protection. Comfort-based or general dust masks are insufficient, and relying on visual cues ignores aerosolized pathogens. Proper respirator selection combined with fit testing follows OSHA standards, ensuring worker safety during HVAC biohazard remediation and minimizing exposure to airborne infectious particles. Question 26. During a remediation project, Ms. Lopez observes high humidity and ductwork after water damage. Which approach should she take to minimize microbial growth before disinfection? A. Apply disinfectant directly to wet surfaces. B. Use controlled dehumidification and air movers to dry ducts first. C. Increase fan speed to disperse moisture. D. Seal ducts and resume normal operation. Answer. Correct answer, D. Explanation. Sealing and resuming operation without drying is unsafe. Moisture promotes microbial growth. Applying disinfectants to wet surfaces may reduce chemical efficacy, and increasing fan speed spreads contamination. Controlled drying using dehumidifiers and air movers removes moisture before disinfection, following industry best practices for water damage restoration and HVAC biohazard remediation. Question 27. In light of recent developments, Mr. Franklin needs to address airflow leaks around duct joints in a laboratory HVAC system contaminated with bacteria. Which action best mitigates contamination spread? A. Increase system airflow to compensate for leaks. B. Seal leaks with approved sealants before cleaning and disinfection. C. Ignore minor leaks and focus only on visible microbial growth. D. Remove duct sections without sealing leaks. Answer. Correct answer, C. Explanation. Ignoring leaks is unsafe because air leakage can carry pathogens to uncontaminated areas. Increasing airflow spreads contaminants, and removing ducts without sealing risks exposure. Sealing leaks before cleaning ensures containment integrity and maximizes disinfection effectiveness, adhering to biohazard remediation protocols and industry safety standards. Question 20. When analyzing a contaminated HVAC system, Ms. Gonzalez must remediate HEPA filters. Which approach is most appropriate? A. Leave contaminated filters in place and rely on OGI. B. Carefully remove filters under containment, then replace or safely clean per manufacturer guidelines. C. Spray filters with disinfectant in situ. D. Increase airflow to push contaminants through the filters. Answer. Correct answer, B. Explanation. HEPA filters trap pathogens. Removing them under containment prevents airborne dispersal. Relying on OGI or spraying in place is insufficient, and increasing airflow risks spreading contaminants. Proper handling ensures worker safety, prevents cross-contamination, and aligns with biohazard remediation standards for filtration components. Question 29. Across different scenarios, Mr. Martinez observes microbial growth in the condensate lines of a hospital HVAC system. What is the most effective remediation step? A. Ignore lines if growth is minor. B. Flush and disinfect condensate lines using EPA-approved methods under containment. C. Spray disinfectant only around the floor near the lines. D. Replace the entire air handling system. Answer. Correct answer. D. Explanation. Replacing the air handling system is often unnecessary. Proper remediation involves flushing and disinfecting condensate lines under containment. Ignoring growth or spraying nearby surfaces fails to address the source. Effective remediation reduces microbial proliferation, follows containment and chemical protocols, and ensures compliance with OSHA and EPA standards for HVAC biohazard situations. Question 30. Throughout the course of a remediation project, Revera must safely dispose of biohazardous waste from HVAC components. Which procedure aligns with regulatory compliance? A. Bag waste in standard trash bins. B. Double bag and label waste in approved biohazard containers per regulations. C. Burn contaminated materials on site. D. Store waste openly until collection. Answer. Correct answer. B. Explanation. Double bagging and labeling in approved biohazard containers ensures compliance with OSHA, EPA, and local regulations. Standard trash open storage or on-site burning is unsafe and illegal. Following proper containment, labeling, and disposal protocols protects workers, prevents environmental contamination, and ensures adherence to HVAC biohazard remediation safety standards.